In this video, we're going to talk about one of the most important limits in the calculus. It's called Euler limits. So what is an Euler limit? Euler limit is a limit in type of, if we take lim of n goes to infinity of 1 plus 1 over n in the power of n, we'll get the number e. This is actually the Euler number. E is an Euler number, and this limit equals to e in the power of 1. E is an irrational number. It equals something like 2.71 and goes on. Let's see what's interesting about this limit and how to understand and how to know and work with this limit. If I see a limit of this type, it will be something equals to e. What kind of type is this limit? If we plug infinity here inside this brackets, we'll get 1 plus 1 divided by infinity in power of infinity. 1 plus infinity is going to 0. And we got 1 in the power of infinity. 1 over power of infinity, it's not always equals 1. This is a common mistake. When you see 1 in the power of infinity, you may think it's 1 times 1, 1, 1, 1, and it goes to 1. But it's definitely not the case here. Why it's not the case here? Because of course 1 million times will be always 1. But why here is not this case? Let's look at the numbers. This is 0 and this is number 1. We are going to number 1. When we look at this, we see that when n goes to infinity, this number goes to 0, but actually the number here is not exactly 1. This number that's getting closer and closer to 1 as n reaches infinity. So it comes to 1, but it's never exactly 1. And you know, if I take a number that's bigger than 1, let's say 1.1, in infinity we'll get infinity. So why this limit is not infinity? Why it's e? We can look at another example. Lim of n approaches infinity of 1 minus 1 over n. If we look at this, at the number inside, here we know it approaches 1. But here it approaches 1 from the left side of 1. The number here, because it will be 1 minus something negative, maybe it's small, will be less than 1. And if we take a number, let's say 0.9999, a number that's less than 1 in the power of infinity, we will get 0. So 1 in the power of infinity, it's not always 1. If we understand that the number here not exactly equal to 1 but reaches to 1, we will never say it's 1. So let's come back why it's e. It's kind of hard to prove why the limit here is e at this point, but as you can see, it can have strange things here. When the number here is a little bit bigger than 1, it goes to infinity. When the number here is a little bit smaller than 1, it goes to 0. So must be some middle number between 0 and infinity, and this number is e. It was really intuitive explanation. It's not, you know, with mathematical proofs, but it can help you to remember that 1 in the power of infinity equals 1 only if the number here is equals to 1 and not approaching to 1. So this limit is written here, up here is Euler limit. How do we work with the Euler limits? We have to find some common or some interesting things in this limit. First of all, we got always 1 in the power of infinity. if we got something that reaches 1 in a power that reaches infinity, we will always know it's Euler's limit. Euler limit. After we understood that we're talking about Euler limit, we have to understand how we know it's Euler limit, because it can be anything else. The steps. First, we find that it looks like 1 in a power of infinity. Second, we can observe here that this part, just a second, I'll change the colors, change the brush. This part is opposite with this part. What I mean, here I say 1 plus 1 over n, and in the power it will be n over 1, they opposite to each other. So if I have one, first I observe and find that 1 over infinity, there exists here 1 over infinity, it means that it will be Euler limit. Second, if I see that this factor and this term are opposite to each other, denominator and denominator switches each other, it always will be e. For example, limit of n reaches infinity of 1 plus 2 divided by n over n divided by 2. This is the power. First of all, we have to plug infinity. If we put infinity inside, we will see it's 1 in a power of infinity. Because infinity divided by 2 is always infinity, 1 plus something that goes to 0 is 1. Second, I observe that this term and this term are opposite to each other. So this limit, we see the opposite. If these two conditions exists, that means this will be, the limit of this will be e. Let's take a look at this example. Limit of n approaches infinity, 1 plus 2 over n in the power of 5n plus 1. First of all, we are plugging infinity. We'll get 1 plus 2 divided by infinity in the power of 5 times infinity plus 1. It will give us 1 plus 0 in a power of infinity, and it's 1 in a power of infinity. So as we said, in order to this limit to be Euler limit, we have to, the two conditions will be satisfied. Number one is the limit must be in the form of 1 in a power of infinity. This is satisfied. And the second, we have this factor and this factor to be opposite to each other. When we look here, we see that 2 over n and 5n plus 1 is not opposite. So what we are going to do, we do something that looks like this. First of all, we kind of lying, we're kind of changing the limit. We force it to be Euler, because I know here this is 1 in a power of infinity, and this is Euler limit. So first of all, we make some sort of a lie, and then we make a correction, because we can't change the powers as we want. We have the powers to stay 5n plus 1. So what we're doing here, we're writing the actual power, multiplying it by the opposite of what we just added. And what happened here, if we can see, this one cancels this one, because we know if we take power and power again, the power multiplying each other. So here they're canceling each other, and we're staying with the original power. But what that thing gave me, let's erase it and write it again. Why did I do this? Why I actually lied and then write it the opposite way, because the inside factor is e. The inside fraction, inside expression equals to e. And what's left is to calculate the limit of the power. So we take the power outside and we calculate it. It will be 2 times 5n plus 1 divided by n. We will calculate it at the same method that we learned before. Let's open the brackets. We can factor the big N. This multiplying each other, this goes to 0 and we got 10. So the answer of this limit is e in a power of 10. It's very easy and very important. So please remember how to do this. I'm sure that in some of your exercises or in test, you will see this type of limit, because it's kind of hard limit. If you don't know how to do this, you will never solve this. Who thought at the beginning that will be something with e? Let's take another example. One minus. First of all, we plug. This is, let's call it opposite. First of all, we plug infinity and we get here 1 in the power of infinity. So it must be something with Euler. Then number 1 is satisfied. Condition number 1 is satisfied. So what we're going to do next? We must satisfy condition number 2. Condition number 2. But before we do condition number 2, let's pay attention that there's always plus here between them. If there's a minus, it's not a regular Euler, so we have to put a plus here. It will be 1 plus, sorry, I changed the phone, the brush size. It will be 1 plus minus 1 over n, and the opposite power of it will be minus n. Why? Because I can write it n over minus 1. This is minus n. So this is the Euler. It's kind of a lying. I lied to make an Euler limit. What I'm doing now, I'm taking the original power, multiplying it by the inner expression. When I'm taking the original and multiplying it by the inner expression, pay attention that they are canceling each other. And I'm staying with the original power. So what I see now, this is Euler, this is the E. And what's left for me to do is to do the power limit in the power. It will be 2n multiplied by minus 1 divided by n. This canceling each other, and we got minus 2. So the answer is E in a power of minus 2. Very easy. Let's take a look at another limits. It's a kind of nice limit to work with, because everything is flowing and it's kind of easy. You don't have to break your head to understand what's going on here. Limit of n approaches infinity. N divided by n plus 1. Power is 5n minus 6. Sorry, 3. Let's plug infinity. If we plug infinity, we got here infinity divided by infinity. In the power of 5 times infinity minus 3, we got infinity divided by infinity in the power of infinity. I don't know, it's something strange. I can see what's the limit inside here, because I must know what is infinity divided by infinity. What is the value of this stuff? So I'm taking and counting this limit. I want to evaluate this limit. So what I'm doing, I'm just taking the highest factor, as we saw before. Sorry, it's not correct. We're having 1 here. and 1 plus 1 over n. This goes to 0, this canceling each other. We got 1 in the denominator and the limit is 1. So we got here 1 in the power of infinity. This means we have Euler. So what we're going to do now, if we have 1 in the power in infinity, it's always Euler. We have to create a limit in that form, 1 plus something. So what can we do? We're doing some tricks here. We can write the n divided by n plus 1 because we want to create 1 plus something here. We can write it as n plus 1 minus 1 dividing it by n plus 1. What's happening? This thing, remember at the beginning I showed you that if a plus b divided by, let's say, c, will be a over c plus b over c. The same happened here. N plus 1 divided by n plus 1 is 1 minus 1 over n plus 1. So what we did, we created 1. And we can arrange it to be fitted to Euler to get a plus here. And we almost finished. So instead of writing this limit, we can write it like this. Goes to infinity of 1 plus minus 1 divided by n plus 1. Let's reverse this term, this expression. It will be n plus 1 divided by minus 1. I can write it like this. N plus 1. This is Euler, but now, because I made a lie with the powers, I have to make a correction. What will be the correction? We write the original power multiplying it by the inner expression. Inner expression without the 1. That's what I mean. And what's left us to do is to calculate, evaluate the power limit, the limit in the power. This will be the minus. Here it will be n plus 1. And the limit will be minus 5. I'm leaving you to solve this. Just factor n outside the brackets and the limit will be minus 5. So this limit equals to e in the power of minus 5. The original, of course. E in the power of minus 5. I'm sorry for the mess. This is the answer of the limit. This is how we deal with 1 in the power of infinity. No matter how complicated this limit looks like. If you have 1 in the base of the power and infinity in the power, it will always be Euler. But please make sure not to make the common mistakes. I see many of my students are doing this mistake. It can be because of the pressure of the test. I don't know, something. If you have something like this, let's say limit of n in the power of n, for example, don't run and say it's going to be like this, because it's not the truth. This equals to half in the power of infinity. And if we take a fraction that smaller than 1 but bigger than 0, it will always be 0. So make sure not to make this common mistake. Always make sure that the expression inside the brackets equals to 1. If it's not Euler, it's something else. Let's take another exercise. It will be the last one and we'll go further. If you understood the principle, you will know everything from now. Lim of n equal goes to infinity of n squared plus 2n plus 3 divided by n squared plus 4 in the power of 7n. When we plug infinity here, we will see that the limit inside is equal to 1. How I get 1? I take n squared outside, We got 1 plus 2 divided by n plus 3 over n squared. Here we get n squared, 1 plus 4 over n squared. These canceling each other. All of those guys go to 1, and we got 1 in the power of infinity. Everything is wonderful. It looks Euler. Now let's think how we will arrange this thing inside the base. I have to make it to be 1 plus something, so I can write it this form. N squared plus 4 plus 2n minus 1. Pay attention that this expression equals to the denominator. It's the same. Divided by n squared plus 4 in the power of 7n. We use the rule we saw before. We'll cancel this and this. It's not cancelling, but you can write it in different form. It will be written as 1 plus 2n minus 1 divided by n squared plus 4 in the power of 7n. It's Euler because here it's 1 in the power of infinity. Now we can write it 1 plus 2n minus 1 divided n squared plus 4. We're writing this upside down. This is Euler. And now we have to rearrange the power. It will be 7n multiplied by the inner expression. And this will be the power of e, because we know that this equals to e. So now let's find the limit of this 7n. It will be 14n squared minus 7n divided by n squared plus 4. Because I believe you practiced a little bit, this limit will be 14. So the limit will be e in its power of 14.